Hello everyone and welcome to my new video. This is the first part of a series of videos where I'll be walking you through the user pool basics, which is part of the Cognito service. In this post, I want to tell you a few things about user pool. I will describe what a user pool is and how it works in separation without connection to an identity pool. I will create a simple pool and use AWS CLI to sign a user up, in and out. I will also describe what it means to sign a user in and what's all about those tokens you received at the end of the sign-in process. You'll also find here a CDK application you can deploy to follow along. In the next parts of this series, I will explain all other components of the Cognito service as well as more details about the user pool. When I first skimmed through Cognito's documentation, I had a vague idea of what a user pool is, but quickly got lost in those users' identities, identity providers, federated identities, not to mention federated users. It is terrific when you already know a lot about Cognito and are just looking for a quick reference to get some details. But it was a bit daunting when I tried to grasp the basics. In a series of video posts, I will do my best to explain in simple terms what a user pool is, what it's not, and what you can do with it. In essence, a user pool is a user database with some additional cool features, or if you prefer, an identity provider. The term identity provider or identity broker, which is technically the same thing, pops up in the documentation quite a few times. An identity provider is any system that can identify a user, not necessarily a human user, but to keep it simple, let's just talk about the human users, and provide details about him or her. It answers one simple question: are you who you say you are? In Cognito, a user pool can confirm who you are in several ways, like checking your username and password or performing a multi-factor authentication. There are a few ways we can add users to our database. We can create users as an admin of a pool, we can allow users to sign up themselves, and we can mass import users using a CSV file. As I mentioned before, a user pool is a database. It can store a lot of information about the user. This information is stored in the form of attributes. We can use both standard attributes, the built-in, like email, family name, gender, and so on, or we can create our own custom attributes. We can also choose how we want our users to sign in, using their email, phone number, or maybe a username. We can enable password policies to enforce strong password. We can enable multi-factor authentication. Here we can either use SMS as a second factor and the so-called TOTP, time-based one-time password software token, like Google Authenticator. Users are also able to recover their accounts in case they forgot their passwords. This can be done using an email or a phone. Alternatively, the pool administrator, so someone with AWS credentials allowing admin access to the pool, can reset the user's password. Since a user can send emails, we can configure some of their attributes to match our project's requirements. The above are just some of the things we can do with a user pool. I'll not go into all of the features here because many of them are topics for their own posts. Let's create a simple pool and sign the user up. For that, I prepared a CDK application that will create and configure all the necessary resources. You can find the source code on GitHub. The link is in the video description. If you want to follow along, use the instructions in the README file. The CDK app will deploy a very simple user pool named MyTestUserPool. With that pool, we should be able to sign a new user up and then sign in. Because this is the simplest possible version of a pool, I will demonstrate how it works by using AWS CLI, although we could, of course, do the same thing by calling AWS APIs with an SDK. Let's quickly talk about the environment. There are a few requirements for it. First of all, you're going to need a node version 14 or higher TypeScript version 4 or higher, CDK in version 1.83, and also you will need a configured AWS credentials so that you can run AWS CLI commands. If you are using VS Code, there is a .dev container setup you can use to open this project in a container. Autolink is already installed. It requires your AWS credentials to be configured in your home folder under .aws directory. I already have my environment up and running, so let's quickly install everything that we need. We go to the CDK directory and we need to run npm install. Okay, now we need to run the npm build to build the actual CDK application. Okay, the application is now built, so we can grab this line and simply deploy the CDK application. In the response, we will see two values we are going to need later, the client ID and the user pool ID. I'm going to quickly copy this over to another file so that we can easily use it later. All right, now to sign up a new user, run this command. All we have to do here is to replace the client ID value with the actual value from our stack. Okay, now our user is created, so we have to confirm it, and we can do it as an administrator of a pool. We have the right to confirm an account. This time we have to replace the value of the user pool ID. Okay, no errors. That it means that the user is now confirmed. Now we can, for example, add this user to a group. We are again going to do this as an administrator of the pool. So we need the user pool ID. Great, no errors, so everything should be fine. When we are talking about the user pool only, so no identity pool, the user group has no special meaning. It's an association we can use in our application when we decide what kind of permissions we want to assign to a user. Let's sign in to our newly created account. As an end user, we do it by initiating an authentication flow like this. Here we also need to replace the client ID. Since we are using standard username password approach, the request will not just initiate the process, but will sign us in. And now comes the most important part of the process. The moment we logged in, we received a set of JSON web tokens. These are the so-called bearer tokens. This means there is no need for a session to be opened between the client and the server. Whoever holds those tokens, assuming they haven't expired and haven't been tampered with, is considered authenticated. We can decode the ID token and the access token ourselves on a website like jwt.io. Let's quickly start with an ID token. As I mentioned before, an identity provider confirms if we are who we say we are. And if that's the case, the user pool will return the information it stored about us inside this token. Here is how it looks like after decoding. So now our application knows who exactly signed in. Even though I wrote that the user pool is all about authentication, it does one thing regarding authorization. It tells us what our user can do. We can see it in an access token. Let's quickly try to decode it on this website. You may now wonder how AWS may know what our user is allowed to do when we have never told it anything about it. In the simplest pool, our user will always be allowed to read and update own information. What we are allowed to do is stored in the scope field. Here we see an AWS Cognito sign-in user admin scope. It allows us to call some of the operations of the user pool's API. You can find the full list of the operation on the API reference webpage, a link you can find in the description of this video. If an operation requires only an access token, we are able to call it. For example, the getUser. Here we need to replace the value with the access token. In the most basic setup, that's all the access token can tell us about what we are able to do. There is a way to extend it, but I will get to it in another post. As I've already mentioned, the authentication process ends when we receive the tokens. Now that we have them, what can we do? First and foremost, the application that received those tokens now knows who we are, and based on them or the group we belong to, can decide what we are allowed to do. Although we are not really limited to use those tokens in this one app. For example, we can make requests to other applications in our ecosystem and send the ID token and our access token alongside. Those applications could then make use of the information from the tokens to decide if our user is allowed to perform the requested action. Both an access token and an ID token carry another important information: when they were issued and when they expired, the IAT and EXP fields. We need this information to check if the user can still be considered authenticated and to refresh the tokens if they expired. The purpose of the refresh token is rather straightforward. If our access token and our ID token expired, we can use the refresh token to obtain brand new tokens. Imagine the following situation. We sign in from several different devices. That means we also received several access ID and refresh tokens, different per each device. The thing is, there is no way to sign out from just one device. The only thing we can do is to invalidate all tokens at once using the global signout action. To test it, let's sign in for the second time, sign out using the second access token, and see what will happen if we try to use the first access token again. Let's start by signing in. We're going to again replace the client ID. And in a response, we received a new access token. Now let's sign out with this second access token. And now try to get the user information with the first access token. Even though we provided a specific access token, the sign-out operation will invalidate all issued tokens. And as of recording of this video, there is no way to invalidate only some of the tokens selectively. Cognito's documentation for the global sign-out action says that the user's current access and ID tokens remain valid until their expiry. While this is true, we need to remember that this applies only to Cognito. If we try to use a revoked token, it will lead to an error. But the fact that the token has been revoked is only known to Cognito. Our application might still be blissfully unaware that the token it holds have been revoked. It's because we only have the information contained in the token. It's important to know that when we architect our application and consider using Cognito, because tokens can never be invalidated outside of Cognito, but only expired. If you are following along, you can now go and destroy the stack.